All right. Okay. So what we're going to do here is we're going to look at program modules in JavaScript are basically functions. They are programmer-defined functions that you can write. We'll look at a couple of examples, square and maximum. We'll look at programmer-defined functions are just functions that you write yourself. Random number generation, we'll look at that as an example, which is used for things like simulating games. Most gambling or gaming computer systems use that. Again, we'll look at some of the new features of HTML5 audio and video elements. Talk about scope rules, which we talked about a little bit about last week, that don't quite work the way you'd expect them to work in loops. They should work correctly in functions, though. JavaScript global functions, some stuff that JavaScript provides for you. Recursion, which is a way of doing the same thing that iteration or loops does, and we'll compare them. So to develop a large and maintain a large program construct, constructed from small, simple pieces, divide and conquer. So this is sort of been the philosophy of developing software since at least the late 60s, early 70s. The entire Unix operating system, which is built on the C programming language, which came up with this first module and was the operating system for the original ARPANET that became the Internet, was all based on this philosophy to create small, simple pieces to divide and conquer. So, and that philosophy continues to today. Actually, it really was the precursor of the whole object-oriented concept, which is built on that philosophy as well. We're going to combine different functions that we write with pre-baggage functions and objects available in JavaScript. So JavaScript gives you a lot of stuff, but it's not generally enough to write your own application. You have to do a lot of your own stuff as well. But you can combine them in almost any combination you want. And so you got each function doing a little part of the program, and that's easier to build it, like building blocks, also easier to maintain and debug. We'll look at some of the built-in stuff. With JavaScript, there's the math object. That's very important. Gives you a lot of mathematical functions so you don't have to remember those formulas. You don't have to be a math whiz. We'll also look at some other objects that give a rich collection of methods for performing all kinds of common things. The math class, for example, is a really good example. Also with dealing with time and date functions and array manipulations, which can be complicated. You can define your own functions, as we said. They're called programmer-defined functions. They used to be called user-defined functions, but they're programmer-defined functions. Perform specific tasks and use them at many points in the script. So they're reusable. Functions are reusable. The actual statements defining the function are written only once and are hidden from other functions. Functions are invoked by writing the name of the function, followed by a left parentheses, followed by a comma-separated list of 0 or more arguments, followed by the right parentheses. So we've used some built-in functions already. When you use the alert box and the confirm, those are all examples of built-in functions, part of the Windows object. So we've already used functions, so you should be familiar with that sort of syntax of the parentheses and putting values inside the parentheses. That's a way data is passed to functions and methods. And methods are really just functions that belong to an object. That's all they are. A function can be freestanding, and then it's a function, or it can be a part of an object. And when it's part of an object, it's generally referred to as a method. But otherwise, they're really the same thing. This gives you a little breakdown. You have, what this is that it's a sort of a combination of saying that you have the boss is generally the starting point, and then the boss might call a couple of different functions, and those couple of different functions might call a couple of different functions, and it can really mushroom out. So, and then eventually, though, the arrows go in both directions, so everything that goes out eventually comes back in. And that's sort of the whole hierarchy of the boss function, which is just the first function, and all the worker function relationships. So, programmer-defined functions, generally you have a return statement, although this can be implied. There can be an implied return statement. But there's always a return statement. Either you explicitly give the return statement, which you have to do if you want to return a value from the function, or it can be implicitly called if you don't want to return it. General function format of a function is the keyword, then the function name, which is whatever name you want to give it, then a list of parameters or values, and this could be none at all, or it could be 10, or whatever you want it to be. And then it's a block of code of declarations and statements that have to be enclosed in the curly brackets, just like loops and if statements. So in our first example, we'll see in a second. Which gives us a bunch of numbers. We can look at this source. Okay, so in here, it's going to call a function called square, which returns p number times p number. So function square we wrote ourselves. And we have a for loop that is, this over a little bit, that starts with 1 and goes to 10. And it simply shows you the square each time. Let's see what's going on here. Sorry, some stuff starting up here. And we'll see that in here as well. We got the for loop that just goes 1 to 10, and it calls square, which is the function we write. Our user-defined function is square. And our user-defined function, again, function is the keyword. Square is the name we gave it. Y is the variable that will hold the argument passed to it. And then we got our curly brackets, because it all has to be enclosed in curly brackets. And then the one command, it's not doing very much. It says return y times y. So it just basically returns y times y, which is how you square a value. You should all know that. And then we're returning it back. And that gives us an output of 1 is 1, 2 is 4, 3 is 9, and so forth, down to 10 is 100. And that's how we get that. Any questions on this example? You want to use the return value if you're going to return a value. That's required. It's a logic error if you don't put it in. If you're not going to return a value, it don't really matter. But in this particular case, we're returning a value, so it does matter. Okay, next. Programmer-defined functions, 3 ways to return control to the point at which a function was invoked. Well, there's really only one way. If you reach the end of the right bracket, then there's an implied return statement. There's really only one way. It's return. There's 3 variations on it. One is that it's implied or implicit because it reached the right curly bracket and it just throws in a return automatically. The other is issuing a return without any value. You do it yourself. And the third is returning a value. So there's really only one way, but there's 3 variations on it. When a return statement executes, control returns immediately to the point at which the function was invoked. So, if we looked at this example here again, view source, we would see that as soon as this return is executed, the program returns up to where it was called, and it continues in the loop. So each time it's going to jump from here to here, and then the return statement is going to send it right on back. It's almost like playing catch with your friend, right? The for loop tosses the ball to the square function, which eventually tosses the ball back. It's almost like playing a game of catch. The script in our next example uses a programmer-defined function called maximum to determine and return the largest of 3 floating point values. Okay. That's fairly straightforward. It's going to prompt us for 3 values. It's going to convert each of the 3 values to float using parse float, and then it calls maximum value 1, value 2, value 3, and then it will return it. So all maximum is doing is it's returning max.max x, and then it's passing into there max.max again, y and z. So the inner one executes first. That's an order of operations, just like math. And it compares y to z. And then the larger of those two will then be used as an argument to the outer math.max, comparing it to x. And that, in fact, will determine which of those 3 values is the largest. Alright, so give it a value. And it comes in, it says first is 536, the maximum is 6. And we have that same source code right here. Any questions on that example? Not again, so they did a bunch. You can do this as many times as you want. Links are on my website and try it out, but it's going to give you essentially the same values. All variables declared with the keyword var in function definitions are considered local variables. That means that they cannot be accessed outside, can only be accessed in the function where they define. A function's parameters are considered to be local variables. There are several reasons for modularizing a program with functions. One is divide and conquer approach, makes program development more manageable. Software usability, and avoid repeating code in a program. All 3 of those are valid. Those have been 3 guiding reasons for at first creating functions, and then later on creating objects. Because object-oriented languages were created for largely the same reason, but also to create a better way of doing it. Any questions so far on those examples? So when it says you can't have this right here, let's see. Yeah, so what it means is this was X, Y, and Z would be an example. So I can't just say alert Y. That won't work. If I try and go back to this, eventually I'll probably get an error message. That worked. We didn't get an error message. We didn't get the alert box. We didn't get an error message either. Probably did get an error. Let's see if there's any way of figuring out the error. It's just not showing it to you. Let's see if we have a... yeah, we probably don't have the debugger on this one, so we can't see it. We'd have to go into Firefox. But in any event, that would be a syntax error. Or syntax error. If a function's task cannot be expressed concisely, perhaps the function is performing too many different tasks. If it usually it's usually best to break such a function to several small functions. So it should only do one thing. And the name should be meaningful to what it's doing. So, for example, here, if we look at the source again, we see that maximum is just comparing the maximum of 3 values. Now, if I had this thing doing several different things, and then you'd want to give it a name that is meaningful, and you see that you're getting a really long function name with multiple different words in it, and the function body itself is starting to get really, really long, then that's a really good sign that you've made that mistake. And you need to break the function into 2 or more functions. Redefining a function parameter as a local variable is a logic error, so you can't do that. That we ought to be able to demonstrate here, hopefully. So this should give me an error if I say var x equals 2 or something. And I say apply changes, and I go here. I didn't give an error. I'll give an error. Let's try this again. This should give an error for sure. Let's see here. Didn't do anything, but it didn't give us an error message either. I almost think we need to use Firefox for this instead. It doesn't seem to be showing us the errors. So first of all, let's try this one that we said should work and didn't.